Andy and Ben. Let's play a game. I have two different natural numbers, x and y, both greater than 1, with some less than 99. Can you find the value of x and y? Hey Andy, the sum of the two numbers is s. Now guess the value of the two numbers. Hey Ben, the product of the two numbers is p. Now can you find the value of the two numbers?
I cannot find x and y, but I'm sure that Ben cannot find them as well.
Yeah, you are right. I couldn't find them just now, but now I can.
Aha, so can I.
Yeah, well done. You are so clever. Let's analyze their conversation one by one. For convenience, let s equal to x plus y, p equal to x times y. When Andy saw the value of s, how could he deduce that Ben couldn't find x and y?
First, let's consider, in what condition can Ben find x and y easily? It can be that p is the product of two prime numbers. Why is that so? Let's take example. If p is equal to 21, it can be only expressed as 3 times 7. So when Ben knows the value of p, he can find out x and y must be 3 and 7. But if p equals to 24, for example, it can be 3 times 8, 2 times 12, or 4 times 6. So Ben cannot know for sure which is the set of x and y that he's been looking for. Thus, we know that s cannot be a sum of two prime numbers. Besides, according to the famous Goldbach's conjecture, if we have a number a that is even and is greater than 4, it can always be expressed as the sum of two prime numbers. Thus, s cannot be an even number as well. Besides, s minus 2 cannot be a prime number. Why is that so? Let's consider the contradiction. If it is a prime number, then x and y, one must be 2 and the other is a prime number. Therefore, Ben can also find p easily as expressed as 2 and a prime number, so he can find x and y easily. In addition, s must be less than 55. If it is equal or greater than 55, then x and y, one can be 53, which is a prime number. And since x plus y is less than 99, Ben can also find that when he finds that one of the factors of p is 53, then x and y, one must be 53. And the other he can also find out by dividing p with 53. To conclude, we have known from the above mentioned conclusions that, firstly, s must be an odd number. Secondly, it must be less than 55. And thirdly, s minus 2 must not be a prime number. So we narrow down the value of s to any of this set V: 11, 17, 23, 27, 29, 50, 35, 37, 41, 47, 51, and 53.
Since Andy and Ben are supposed to be clever enough, what we deduce above is also known by Ben. Then, how can Ben find x and y from Andy's words?
So Ben will know that the sum belongs to the set V. So Ben analyzes all the possible factorization of P to obtain all the possible x and y and the corresponding Si. So if among these all the possible S, only one of them belongs to V, then Ben can easily know that this Si is the sum obtained by ND. By programming analysis, we obtain this set of data. So what does this mean? Let's take an example. For example, this set, it means that when P is equal to either 18 or 28 or 24, by analysis, Ben can know that the sum of x and y should be 11. For example, if P is equal to 24, 24 can be the product of 2 and 12, or 3 and 8, or 4 and 6. And the sum of these two is 14, and sum of these two is 11, sum of this is 10. And only 11 belongs to the set V. All the others does not belong to set V. Therefore, Ben will know that the sum is 11. So he will know that x and y will be 3 and 8. So in sum, by analyzing what Ben has said, we can conclude that the P must belong to one of these sets, depending on what the value of sum is.
Now that A knows the sum of x and y, how does he find out exactly what are x and y? Well, he knows that P must belong to this number, but only when the DPFS set has only one member, then he knows exactly what are x and y. Let's find out why. If S is 11, P can belong to this set, so it can be anything among 18, 28, or 24. So A cannot find out x and y immediately. But if S is 17, P can only be 52. Now that he knows the sum and the product of the two numbers, he can easily find out x and y must be 4 and 13. Thus, we can conclude that S must be 17, P must be 52, and we can find x and y to be 4 and 13, and our problem is solved.
Now, let's go through the logic flow of this puzzle with the answers. So when Andy gets the sum 17, he cannot find the value of x and y simply from 17. In addition, he knows that 17 cannot be a sum of two prime numbers, so he claims that Ben cannot find x and y simply from the product. On the other hand, when Ben gets the product 52, from what Andy has said, he knows that the sum should belong to this set V, so Ben factorizes 52 to get 2 times 26 and 4 times 13. And the sum of 2 and 26 is 28, which not belong to this set V, whereas the sum of 4 and 13 is 17, which do belong to this set V. So Ben will know x and y are. So from what Ben have said, Andy knows that the product should belong to the DPFS set, depending on what the sum is. And of course, Andy knows the sum is 17, so he knows that the product can only be 52. Therefore, Andy knows that x and y are 4 and 13.
At the first glance, this puzzle looks unsolvable. The three sentences in the conversation appear meaningless because they don't even mention a number. It seems impossible to know what they have known simply with the information about whether they know or not. However, by detailed logic inference of the information hiding behind the meaningless sentence, we are able to narrow down the range of values step by step and finally found the answer. But we have to admit that despite logically magnificent, the process of the inference is not logically perfect. For example, when we analyze the second sentence when Ben say, "But now I can," the main logic model we utilize is if P is true implies Q is true. Therefore, if Q is true implies P is true. And this is actually a hasty inference. In other words, our deduction, If the product of the two numbers belongs to one of the set, implies that Ben is able to find the value of the two numbers. Therefore, if Ben is able to find the value of the two numbers, implies the product of the two numbers must belong to one of the set. And this might not be true, as P implies Q does not mean that Q implies P. The correct proving procedure is that we have to prove that the product of the two numbers belongs to one of the set is a necessary condition for Ben to be able to find the value of the two numbers. Therefore, we can only conclude that 4 and 13 is one of the answers for this question.